topic that we have started yesterday, and that is delegate. And yesterday I told you delegate is nothing but it is a function pointer. So it's a pointer to a function. However, we are all familiar, C# does not support pointer manipulation directly. So these pointers are encapsulated in a reference type. So it's a very different type. So we have seen integer, we have seen float, we have seen class, we have seen interfaces and so on. Similar to them, we have a different type called as delegate. So delegate is also a type. So let's look at what is this particular delegate is doing. Delegate is a function pointer, but it is type safe. One of the reasons why we use the delegate is to use it for function callback. So let's look at an example over here, and I have Visual Studio here. Let's say how we can use a delegate. Now, in order to use any type, we require few things. For example, let me take a creation of a object called as or a creation of a class called as a student. Now, you define or you declare the class here. Okay, so you say that student is there. So you give the definition of the student with all the details. Then you come here at some other place. You then instantiate that student. So this is what you are getting. The student of, let's say, yesterday. So this is the other step. And the next thing is you're going to find some methods out of that student. So you notice that there is a pattern. You declare something, then you instantiate it, then you start activating it. The same thing is true when it comes to the delegate. Now when you have a delegate over here, we have to declare a delegate. Now when you declare a delegate, you must, I've told you delegate is a type safe pointer. So when you declare a delegate, you must declare it to point to a certain type of a method. For example, suppose if I have a static method, say static void, let's say static int add, and it takes two parameter int x and int y. So this is a method. I'm going to return something, so otherwise the compiler is not happy with that. So when I have a method here, okay, now if I want a pointer that can point to a this particular method, then I have to declare a delegate. Now how do I declare a delegate? In order to declare a delegate, I first define it. So I'm going to start with the keyword delegate. Then, what is the return type of the method for which you want to point? So this is the return type. So I'm going to say this is the return type. Then give the name for the type of delegate. So I'm going to say this is my delegate, followed by the number of parameters that you want to or that particular method takes. So this is what is the definition as such. So this defines a delegate called as my delegate. Let me again stress the point that I told you in the last class. When you declare something called as student, you will not directly use the student. You create a variable of type student, and then you start playing around with this variable. Similarly, when you create a delegate called as my delegate itself is not used. You have to create a variable of type my delegate. So it is something called as D. So you are going to play around with this D. Okay. So this is the same technique that we are using, whether it's a class or something else. Now the first thing is, if you just create something like student yesterday, and if you start obtaining its method and all of them, student yesterday will be pointing to a null. So you require to instantiate this particular student by calling its constructor. So once you declare a student, you are supposed to call this. Similarly, This is a pointer to a method, but now this is not pointing to any method. So I cannot think of invoking any method inside this. So what is that I am supposed to do? Like the class, I am supposed to say that I want to create a new instance of this delegate. So how I'm doing it for the class, the same thing has to be told. However, this is different from the class. It is different because it knows how to point to a particular function. So I have to declare the name of the function. In this case, I have to say that now this is going to point to this add. So I have declared D as a pointer to this method. So here, it's like when you try to call a constructor, you have to provide the function for which you are going to point to. So once you create this student, let me come back to this student. Once you create this student, you are going to activate a method inside that student. Some method you are going to call out of that student. Similarly, once I have instantiated that particular delegate, I can think of calling the method, or in other words, I can think of invoking a method by supplying some values to it. So after all, D is pointing to a function called as add, and it takes 2 parameters, and I'm supplying it. Now suppose if I write it say inside CW, and suppose if I put it, still is not happy with that. Okay. Now I'm going to just stop this, is not really required. I'm going to use console.read key. I'm going to just run this one. And you can guess what is going to come out. That is, it is 11. The reason it is 11 is I'm trying to call that add method, and I'm supplying 2 numbers which are 5 and 6, and naturally it's going to be 11 altogether. So if I supply that number, it's going to be 11 altogether because I'm just invoking the add method, and I'm giving 5 and 6. So it's as simple as that. You have a delegate, you point that delegate to a particular method, and then you invoke it. Now there are a few twists in this story, and that is one of the changes why, after all, I know that delegate is nothing but a function pointer, and it has to point to a particular function. Then the usual thing is, why do I have to write all these things? Why can't I just tell the compiler that you are pointing to a method called as add? This works fine. This is a very shortcut. You don't have to write new and elaborate it. Just tell the compiler that I'm pointing it to add. Just instantiate it. So this is going to work. The next thing is, after all, this is a pointer to a function. Why do you have to call everything and again elaborate and say that you activate it? I can directly do this. After all, it's a other name for it's a pointer to a function. Just invoke it, and this is going to work fine. So if I run it, it's going to give you the same result that you would have expected for a given method. So it is as simple as that. In most of the time, we will be using this as our technique. So this is how you declare and use the delegate. So when you want to declare a delegate, you need to, if at all you want to use a delegate, you require 3 things. One is you have to first declare how the delegate will look like. So I have a delegate, and this has to match the signature, including the return type of the method for which your delegate is proposed to be pointing to, and you have to give a name. So this is your delegate. Now if somebody asks you which is the delegate in this side, the delegate here is my dev. So you have created a delegate of type my dev. Suppose if you create like this, and if somebody asks what is that you have created, you have created a student class. Similarly, you have created my delegate, which is of type delegate. Okay, so let's look at how we can use this in our applications. So let's assume I'm going to give you a scenario. and let's see how we can think of using it. Now here you notice that I have not specified anything when I declare it. Obviously, I can think of using something like program dot add. Program is the class name followed by that. It is always allowed because I'm there inside the same class. There is no point in saying that it is from the same class. It is allowed. Now, if you have it in some other class, suppose if you have a method in some other class, let me say you have a student class, and if you have a method in the student class, let's say you have a public method which returns integer, and let's say total of internals, and it takes 2 internal marks, CP and Q. Again, if you look at it here, I'm trying to give the signature that is same as that of the add method. So it returns something, and you get something. I am not supposed to put a semicolon here. Then I'm going to say returns. You have a lot of things you can think of doing. P plus Q, and let's say it is there inside a other class. Now, how do I make it point to that? In order to make it point to that, I have to first, I can't directly do like this. I have to first create an instance of that student. So I'm going to say yesterday is equal to new student, and then I'm going to make this point to that student. So here I'm going to say my delegate is going to point to yesterday dot and the method. Very important thing, when you are pointing to a method, you are not specifying the parenthesis, and you are not specifying the type. It's not required. You just give the name of the method for which you are trying to point to, not all the details, because this method, this delegate, can point to a function that takes this signature. If you have some other functions, let's say public string get name, let's say, and it takes 2 integer parameter, int x and int y, and you have a lot of things to be done on this method. Say return a string, so it is trying to return, so I've made this function. Now if I say that my delegate is going to point to that thing, so if I say that std dot my delegate is pointing to, I think I have to make it as public, it will not be, it is public state, where is that, then it is std dot get name. If I try to do it, after some time the compiler will complain and say that this is not possible because I cannot use D to point to a function that returns a string. It has to, the signature has to match including the return type. So suppose if I have this method that is trying to return a int, and let's say one of the parameter is different, string or long or anything, and it is trying to return some value. Now if I come over here and it still says that I cannot find any overload that matches here, so this is that function, it is not possible to point to that. So the matching is proper. That is why I've said that it is type safe. Using that pointer, you can point to any function that has the same signature, but you cannot think of pointing to a function that is different. Okay, now you may be thinking, why do you complicate the life by creating a pointer and then try to invoke it? Why can't you just, instead of doing all those things, why can't you just, you wrote B here, then you wrote something over here, why can't you just write a plain old thing saying that yesterday get the total internal and then type 2 numbers? It is, the life is more safer here because we know what you are trying to do, rather than you do something, you declare this, you then point to something else, and then suddenly you say that you are able to execute that function by using a pointer. Why to complicate the life to that extent? The reason will be very clear when I give you a simple example. Let's say I'm going to get rid of that student if it is there, because I'm going to get its student outside. So I'm going to get that student from this space, and let me go over here and let me add a function. Let me add a class. Let me call that class as a student. Let me do something, and at least if not anything, a student will do this one. Okay, and student will do this. Compute result, or this is what student will do. And what you will do, let's assume that you have a total. So this student has a property called as total, which is integer, and the result is based on that total. So here, let's say you create a string result, and I'm taking the default value. As fail, and you have some criteria. For example, if you say if the total is greater than say 475, then it is going to be say result is distinction. I'm just taking some value. Then you have some other criteria, Control C, and else if some other criteria. If it is greater than say 420, then you have say first class. Then you may have some other criteria over here, and you notice that when I am typing, I am getting this line here. Okay? Or if you carefully have observed that thing, in your case, it is you don't get that line. And if you're wondering how on earth that I'm getting that line, is because I told you yesterday there is an extension. You get a lot of extension, and you notice that I'm getting a very different in the last class and this class. This help is different because again I'm using an extension. So when you use an extension, you get you can make your life bit easier by getting those extensions which are free. Let me assume that this is what you have. Now the student has calculated the result, but when the student computes the result, there are other people who are interested in that result. And who are those other people? The other people definitely are the parents who are interested in that. So you have a parent who really want to know what the student has done. And there are other, apart from the parent, there is one more person at least who is interested in your result. And let's say this is registrar. Okay. So registrar is also interested in your result because he has to, after all, issue a certificate to you. Now, what the parent usually will tell you is, once you get your result, you call me and you tell me what is the percentage that you have got. So you will call the parent. In our scenario, in our object-oriented programming, what is the meaning of saying you call is there is a method and you have to just activate. Okay. So I'm going to say of my switcher, and the parent will say, okay, you call me and give the result to me, and I will tell your neighbor, all your relatives about that. Okay. So this is what the parent will say. Okay. So my child has secured. Okay, here is. So this is the scenario, and after all, what the registrar will do. Okay, registrar will also say that register, even though may not be fully involved in it, so registrar will also say, okay, give me that. Okay, so he is going to say result of a student, because he has to make a note of it. So we have this string and this result, and the registrar will somehow is going to write somewhere. So I'm going to use the console write to write that thing, because it's just a demo. So registrar will say that the result of a student is less result. So it is good. Now what is that this student is supposed to do? So there are diagram that will be much faster. So I have a class diagram which is much faster to explain, provided it comes up really quick. So I have command student, register, and parent. 3 people were there. So we have a student, and the other 2 are interested in that one. So what is the scenario here is whenever the student computes the marks, the parent and the registrar is interested in that mark. So you have to somehow call the method of the other type. Now all the time they may not be interested in it. So suppose if you are calculating the internal marks, they may say that don't tell me your internal. So I'm only interested in the final mark. So if they are interested, then you will call and tell. Again, your registrar may not be interested in how much marks you have scored in your class test. It may not make any sense to them. So if they are interested, they will tell you that once you calculate it, you just tell me so that I can update the some place. Okay. So how do we go about it? To get this thing working, we will first go to the main program. Okay. And what we are supposed to do is this student has to somehow point to the 2 methods which are there. So you have this 2 methods, they have to point to the 2 methods. And if you notice over here, the 2 methods what I have written here have the same signature. So what I'm going to do now is I will go to the main program here, and I'm going to create a delegate that will look like those 2 methods. So I'm going to create a delegate that returns y, and I'm going to say this is student delegate, and it takes a string result. It could be anything. Okay. So this is the delegate. And then what we are supposed to do here. Okay. We have to make the student point to, or student somehow has to call that delegate. So let's see how we can think of using it. Okay. So let's go to the, this is the delegate, and I'll go to this student, and the student will create a field here called as a public, okay, student delegate. And you know very well this is has the same method, and what he is going to do is remember, if you just look at this one, it is a reference type, and the default value of the reference type is null. If the default is null, and if you try to activate that function when it is pointing nowhere, that means to say that when it is null, if you try to activate, you get a runtime exception. So what I'm going to do here is, once the calculation of the result is over, I'm going to just go over here, and I'm going to say if my delegate, if the delegate of the student, if it is not equal to null, okay, then that means to say that somebody has somebody is interested in my marks. If nobody is interested, then it just becomes a null. So then there is no point in activating it. Then I'm going to call that method with by passing the result that I have calculated. So whatever result I calculate, I then activate it, provided this is not null. So let's go back to my main program now. Let's see how we can think of using it in our program. So I have the student yesterday, and I'm going to say equal to new student, and I will go for an object initializer, and you are already familiar what is the meaning of saying object initializer, and I'm going to say he has got 480 is the total marks of the student. I'm not supposed to put a semicolon here. So this is an object initializer. So students total is 480 now. So let me put a semicolon here. Now we have a parent of this student. So let's say PARENT. Same. So we have parent. Let me give a proper name to this student. That's easier. So otherwise, it becomes just a student. Okay. I just gave a name to the student, and I also have the registrar and who is your registrar. So if you don't know, Narari is your registrar. This is not a fake name. If you read the calendar, you will find the same name. Okay, he is your registrar. Now, what is that we are supposed to do? We will go to the student, and the Manohar is my student, and he is going to compute the result. What happens now is, if I run this application, you will see a perfectly blank screen because nobody was interested in students' marks. Register said I'm not interested. Parents said I'm not interested. Now let's say that before the student makes a calculation, that says I'm interested in it. So that will go to this Manohar, and he's going to say that you have this delegate, you add me into this. So if whenever you calculate the total, just make a callback to this method. So I have a method called as result of my child. When you do the computation, you just call that method. So you notice over here, there is a value that is assigned to it. Now this is same as writing, if you are wondering, this is same as writing new student delegate and putting everything and making a mess out of it. So this is same instantiating the delegate, and I'm using most of the time I will be using, and not only me, the world will be using a short form of that, which is much compact and much easier to read also. You just assigned it. That means to say that del is assigned a value, it is no longer null. So what will happen? When a student makes a calculation, at the end of the calculation, at the end of this, you notice that if del is not 0, that is not null, it is going to invoke its method. So let me run this thing. I think this time I closed it. I'll just activate that student. Okay, let me run it now. And if I run this thing, you notice here that this time, I'll rerun it again. You notice that student is doing the calculation, but you will see that a message is given to you, and this message comes to you from the parent, wherein the parent says my child has secured a distinction and so on. So here you notice that the student is able to call a method on some other object, and this is done dynamically at runtime. You can either assign or you can remove the value. Now what if Narari also says that no, I'm also interested in it? How do you go about it? So I'm going to say delegate is equal to plus equal to, and I'm going to go to this Narahari, and I'm going to say Narahari has one method called as result of student. You notice that I'm using plus equal to. What is the meaning of saying plus equal to? Delegate plus the old value of delegate plus new one. Now if I try to run this, I'm going to blow it up and then run it. You notice that you receive two messages, one from the parent and the other one from the registrar. You notice that what is happening in this application? There are two sides are there. One is somebody who publishes something. There are others who are subscribing for it. So you have this publisher and subscriber. So publisher publishes something, and the subscribers, if they are interested, they are going to subscribe for that particular event. So something is happening with the student, and there are many people who are interested in it. So when that event actually happens, all those subscribers are notified using this method. So it is a good way of doing it. Now what if after some time, if a parent says that I am not interested in your marks? So how do I do that thing? The parent has subscribed here, and the parent is going to say it is minus equal to. You know what is meaning of saying minus equal to? The delegate minus that. Here you are adding it, at the other place you are subtracting it. So what will happen in this case if I try to run? So the parent is now saying I'm moving out of that result, and you notice that it's only Narahari who is giving the result. So you notice you can actually chain together the method. So it's like a linked list that you have created. So what is after all, what is this delegate that you have created? You have created a delegate which looks like a linked list. In this case, there are two links are there. So your delegate that you have created here, this delegate is pointing to one of the node, and what is there in one of the node? One of the node has a pointer to the method. Here it is pointing, and the other piece is pointing to the next one. This next one is pointing to one more method, and again you can think of extending it again and again and making it a full-fledged linked list. So what you have internally, what you have is a linked list of all the methods or the pointers to the method. You can add them at any time, you can remove them from the list at any time. So this is the speciality of the delegates. So delegates are great because of this. Anytime you can add a method at runtime. Remember, it can be done at runtime. So if the condition is true, you can do that. So based on runtime, you can assign a method to the delegate and make it call that method. And at runtime, you can remove a method from this chain. So this is a very simple technique. Now, if you do this one again, suppose if you add 2 times, Narahari, what will happen? So I'm adding 2 times the Narahari. In that case, what will be the output? So there are 2 things are there. So if I run it, what will happen? If you run it, you will notice that, because remember it's building a linked list, and if you get the analogy of that linked list, what has happened is it has just created one more node for that. So it was after all, it was building a linked list. And when you build a linked list, there is a pointer that is pointing to this, and there is the second one that is pointing to the other one. If you add it 10 times, it's going to call it 10 times. So it's simple as that. Okay. So it looks great, but there is one minor problem with this. And what is that minor problem? The minor problem is, if it is known to you that this is how the Manohar is giving a message to the parent and Narahari. So what you can think of doing, I'm going to get rid of these 2 things. So Manohar has dad who is interested in his marks, and Narahari is also interested in it. And you know very well, this is how the Manohar is making the call. So what you can think of doing, you can just go to this Manohar, and you can go to this del, and you know how to activate it. To activate this, what is you're supposed to put a bracket here and just put this. Okay. In this case, what will happen? Okay, I'm going to remark this. This is the actual calculation that Manohar was doing. Now, because you know how the Manohar is invoking them, you just go outside Manohar and then activate this method. In this case, what will happen? In this case, you will notice that both of them are getting a wrong information altogether. Why? What is the problem? Now here what is happening is there are subscriber and there is a publisher. It's the work of the publisher to invoke the subscriber. But because of this delegate, it is possible for anybody, because I made it as a public field, anybody can invoke this method and then they can create a havoc in your entire program. So this is one of the problems of the delegate. What is the other problem of the delegate? So let's go for this ideal scenario. Now, what if you want to create a havoc in life of Manohar? So what you can think of doing? You can just go over here and you have all the people who have subscribed to it, and finally you just say null to this. Remember, del is a pointer, and you know very well the minute you make a pointer, if you directly assign, I'm not saying plus equal to or anything, I directly assign a null value to it. In this case, what's going to happen is if you run this thing, you will notice that nobody is getting any intimation because all the linked list that was there is pulled out and null is added right at the beginning of the pointer, and now the pointer is a null pointer and nothing is going to happen. So this is one of the problem of the delegate. Delegates are great, but delegate come out with when you are using delegate, you must be very careful. So then, what is the solution for this problem? The solution for this problem is, one is you must not make somebody to directly invoke a method. So that means to say that this delegate must not be, say, you are not supposed to allow someone else who has nothing to do with the invocation to invoke the methods. So you have to prevent that. The other one is you must prevent this direct assignment. If you allow anybody to make a direct assignment, they can make a null assignment to your delegate, and then onwards the delegate will not call anything on that list. Two things have to be prevented. So a direct assignment should you must not allow it, and the next one is direct invocation, and these two things are taken care in other type, and that is the event. So event is a delegate with a restriction, and the restriction is you cannot directly assign a method to the event. If you want to add your method, then you can use plus equal to minus equal to. That means you can add something to the list and remove something out of the list. No direct assignment. So null directly can't be assigned to this. And the next one is events you cannot fire an event outside the class or outside the method in which it is declared. Others cannot fire it. So event has to be fired within the class. If the class says I have an event, or if the object derivation of the class, the object says I have an event, when something happens, the object is supposed to fire it, not the unconcerned person trying to call or invoke or fire that particular event. Now, before we venture into that event, let's look at some of the properties of this delegate. And some of the properties is what are the additional things this particular delegate can do. So let me go to this Manohar, and let me go to the delegate of the Manohar in particular. Let's see how many methods are there. Remember, there is one method that I've already told you, invoke. Invoke is same as directly calling it. Okay. Apart from this, you have two other things. One is the method and the other one is the target. Let's look at that. And we also have one other method called as get invocation list. What is this invocation list? If you are interested at runtime, if you are interested in knowing how many of them have subscribed for this particular delegate. So here, two of them are subscribed. If you want to get that list of classes or list of objects who have subscribed for your method, you can do that thing. So this is an easy way of doing it. So I'm going to use a for loop here. So for each, this is I think a student delegate, and I'm going to just say D in the Manohar dot delegate dot get invocation list. Okay. That put that double quotes. So what I'm doing is I'm asking it, okay, give me the list of all the delegates which are subscribed to this. So I got this D, I'm going to use CW, and I'm going to say D dot, which is the target, and I'm going to make it look like your name resolution that you are using in your C programming language. Okay. And okay. So you are sending a message or? So let's look at that. If you notice over here, I'm going to just before I show it, I will not call that fire that event. And you notice that what it has done. This part console.app, before I show that thing, this is a namespace. By default, it is adding a namespace called as console.app application core. Ignore that thing, it's just a namespace. Let me run it now. So, who have subscribed? The target is parent. So, if you look at this one, target is parent, and the method is void result of my child and this. So, what is this? If you look at the parent, so target is this parent, and the method is this. So, when you say target, what you get is name of the class that has the method, and what is d dot method, which is the method inside it that is getting called. So I told you it is a linked list, and the linked list is pointing to something. So it's a linked list, and this linked list is pointing to a method. So when you say it is pointing to method, the next question is which is the class inside which that method exists. So after all, which is the method also will come. First is which is that class. So that is the target. Inside that class, which is the method. So these are the two things. So you have the class and the method here. Okay, so two things are there. Apart from this, if you go to the delegate over here, let me go to this Manohar, and let me go to the delegate. Then you have something called as get type. So you can get what is the type of this. Now before I do that thing, let me do this. CW. If you ask who is Manohar, then how do you get that? Okay. You ask, get me the type of Manohar. If you ask who is Manohar, after all, then the way in which we ask in the program is we say get the type of Manohar. Okay. So if you run it, your program is going to say Manohar is ignore this part, it's a namespace, is a student. Now the next question is, if you ask what is this delegate that you are talking about, what is this Manohar.del, how do I do that? So I'm going to go to this Manohar.del, I'm going to say get me the type of that. I want to know what is the type of it. Okay, so let me run it again, and you notice that this is of type student delegate. It is not saying it is delegate, or it is not saying anything. It just says it is a type of student delegate. So when I say who is Manohar, it didn't say it is a class. Instead of said, it said it is a student class. So similarly, this is a student delegate. So there is a huge difference between them. Now after this, there are many other methods. We will not venture into those methods. So let's look at what else you have for this. So if I go to this Manohar.del, and then you have this begin invoke and end invoke. if you just look at it, it says it's a asynchronous callback. The calling thread will not wait for the response. That is what is the meaning of it. So when you activate a method, the thread makes a request for something. It will not wait for the response. So the response can come and at any time. So at any order, the response can come. This is asynchronous. What is synchronous? The calling thread makes a request and waits for the response. Only once it gets the response, it starts proceeding. This is synchronous. Okay. So if you have a scenario wherein you call a method, which is that method? If you are thinking, which is that type of method? Suppose if you are making a request on an internet, it's going to take some time to pass that message across the internet and get the response back. Instead of waiting for that entire response cycle, you can just proceed with the current verb, and that is asynchronous callback. So you have this synchronous and asynchronous callback, and there is one more thing, that is the dynamic. If you look at, there is one more invocation, and that is the dynamic invocation. This dynamic invocation is late bind. It is, if you want to, I won't go in depth into it. It is trying to bind at the runtime. If you want to create a delegate at runtime and then fire its event at runtime, then you can think of using that. We will not venture into that kind of thing because I have not got a real kind of example kind of application wherein we can think of getting an delegate altogether at runtime and then trying to put something into it. Okay, so let's before we venture further, let's say what are the other things this particular method can do. Let me go over here and let me create one more delegate. And let me say this returns int, and let me say this is math delegate. I am going to create a class called as maths class, and as usual you can guess what I can think of doing. I can say public int add method, and it takes int x, int y, and it returns x plus y. Similar to this, I have many other methods. I can think of going to a subtraction method that subtracts something. I can think of doing multiplication. That's another thing. I'm going to go for the multiplication method. Okay. Then we have